So in the last post, we saw the problem formulations of the self-learning recommendation systems. We looked at the different, how we can form the different states. We looked into some exploratory analysis and identified some of the states, and then we also went into how the complete system or the big picture looks like. Now what we'll do is, now we will start implementing that big picture, and we'll be doing it in Jupyter notebooks. So let's dive in and let's look at the complete set of processes which we'll be doing in these in building these prototypes. Now the first step which we'll do is obviously pre-processing the data set, because we saw that it's an online retail data set, and we need to do a little bit of pre-processing to make it in the process or in the form which we want. And the second process which we'll do is implement the RFM segmentation. So RFM is one method of doing segmentations, and we will be doing a lot of k-means clustering implementations to build these different clusters of segments, because as we know, segments are one of the important states, and therefore we need to build segments of customers here. Now the third process which we'll implement is the creation of states for building that context for recommendations. So all the states which we require, which includes the segments, the month, the period within the month, the first 15 days and the next 15 days, then the number of days or the weekdays, etc. All these things would be built in the next, after the next process. And then the fourth process is about creation of rewards and value distributions. How we can create the rewards and value distributions, and here we will connect it to the K-bandit implementation which we did earlier in the second post. And fifth process is implementing the self-learning process using the simple averaging method. Here again we'll take the concept of the K-bandit problem which we did in the second post, and then use it to build the self-learning process using the simple averaging method. And the last one is to simulate customer actions and initial self-learning for recommendations. So we will simulate the customer actions. Since we don't have a system, we simulate the customer actions and the self-learning part of the recommendation systems, which is again based on the K-bandit, the simple averaging method of how the update happens. That is, the new estimate is old estimate plus the step size into the return part. We'll be implementing that to build the self-learning recommendation system. So these are the steps of processes, or these processes which we'll be implementing in this post. So in this specific post, we will be doing only the first two processes, which is pre-processing of the data set and segmenting of customer using RFM segmentations. Steps 3 to 6 would be done in the next post. Okay, so let's dive in. So now let's get into the pre-processing steps, and let's open the Jupyter notebook and start coding. So the first part is about importing all the necessary packages. So these are the packages, so let's import them. So once those are imported, let's implement a function first. This function is a very simple function to read a CSV file and load it as a pandas data frame. So that's a very simple function which is here. So let's implement that. So now using that function, we will read the online retail's the file which we online retail data set which we saw in the third post also. When we did our exploratory analysis, it's the same data set. So you can change the file name here to whatever is your path where this online retail file is kept, and then use the above function, data loader function, to load the data. Now let's look at the data set. Anyway, we have seen this data set in the previous post, the third post, during the exploratory phase analysis, but let's recap. So the first one is the invoice number. These are unique for customers, individual invoice number. Then your stock code, which is the code for the products description of the products here, and what is the quantity of the products which we have done. Invoice date, we'll do a lot of processing with the invoice date later, unit price, and then customer ID. So these are basic things which we want. Maybe we won't do much with the country, but all the other things we require. Now next step is to extract a lot of information from the invoice date, like your the weekday, extract which day of the week, then extract which day it is, which month it is, which year is it. All these things we'll do. So what we'll do is we will the first step is to using the parsing function. We have imported the parsing function here. See, the state util parser, we imported the parsing function. So why we require the parsing function is to convert this date into a format where we can extract all the necessary information. So the first step, line 22, is about using a lambda function. So we use a lambda function to parse the dates. So it will go line by line and convert the parse date into, or the invoice date into, a new variable which we have created called the parse date. So that is done in line 22. And in this next line, what we do is, using the parse date, which is the date which we create, extract the weekday. Now for weekday, we just need again apply the lambda functions, and weekday is what is required. This function is required, or this method is required to extract the weekday, in which we store it in a variable called weekday. Similarly, the day of the which day it is, again we use strf time method and extract the percentage a, capital A is what gives you the date, or the day rather, next the month, and year. Similarly, it's all these similar lambda functions which we use, and different arguments which we have to pass for the month and the year. And then we combine the year and month. Why we do the combination of year and month, which we will see later, is for creating the states, which will be easier for us. So let's once you implement this, let's just implement this now, and then let's look at the head. So here we can see all those details which we created, like you have your past date, your weekday, which is your numerical of your days, the day, which is your Wednesday or Thursday or whatever, and then the month, year, and the year month. So we have got all those necessary details to start doing our RFM processes, which we will do next. So one more step which we have to do is, we have only quantity and the unit price. Now we want to convert into a gross value, which would be just a simple thing, the quantity multiplied by the unit price. So that also we let's implement that and look at the gross values, which is here. Now we will start in creating the segments, and for creating the segments, there is a good package called the lifetime package. Let's import that package. If you don't have that package, you can pip install those for your specific use if it is not there. Otherwise, if you already have it, just import that lifetimes package. So the first step towards this, in creating the RFM format is it is available, and it's a very simple line wherein the whole data could be converted into that the RFM format, which is your recency, frequency, and monetary format. So let's do that. So it's a simple one-liner, that's lifetimes.utils.summary data from transaction data. So you give the data frame, and which are those specific variables, like which are required. One is we need the customer ID, the past date, and the gross value. So these are the features which are required to make it into a RFM format. So let's implement that. So here we get the output like this. The first one is the frequency. So you can see that it is aggregated according to each customer ID. So that's the format which we want, and ultimately we want to understand who are the customers and what is their frequency, recency, and the monetary value or what they spend, the wallet share. That's what we require. So so each customer ID we can see the frequency, recency, and the monetary value. So there is one more variable which is interesting here. We will not be using much of it, but just for information. Now there's a variable called the T which has been generated. Now T represents the age of the customer, that is in terms of from the first purchase to what is the latest period. So you can see in the specific unit which we are given. So the data here is in days. So this represents it's the first, say for example the first customer, it's 325 days since the first purchase and the current period. So that is what T is. We might not be using much of this T in our processes. Now what we'll do is for ease of use we will reset the index because now you can see the index is all over the place. Now we'll reset the index so that we know how many customers we have. So let's implement this. So you can see that there are 4,372 rows and 5 columns which we require. Now next process is about building the clusters, and we will be using the k-means algorithm for building clusters. Now any of you who do not know k-means, there are different posts or different links where you can understand what k-means is. So k-means in short is a way of clustering different based on the variables which we choose. So what we will do is we'll cluster. So our ultimate aim is to create customer segments. So the way we are doing creating customer segments is by clustering your these customers according to the recency, frequency, and monetary values. So that's what we're going to implement, and that's what we use the k-means for. So we'll see later on that we will take the recency, build a cluster, then frequency, build a cluster, and the monetary and build a cluster, and then combine these 3 different clusters together and form a aggregated score, and based on that we would be creating the customer segment. So we'll get into that. So first let's import the necessary packages which we want. One is the k-means and the matplotlib for plotting. So first we will take the user recency. We'll do the clustering based on the recency. So let's subset the recency related variable. So only the customer ID and the recency, and then we will take that subset. So let's implement that, and then we will get the customer ID and the recency as this.